So, like the name here, we can see actually before we have two separate programs, the food engineering and biotechnologies. But after a while, they combined together into one single program. So, food engineering maybe for some of you here without a background can simply speaking, we can say that's apply engineering principle to improve the safety, the qualities, and certain production of food products. And by process technology, mostly we talk about applications and development by technologies for functional foods, for kind of nutraceutical, whatever, in those areas. All right. So Dr. Data has mentioned about our thematic area here. I will not repeat it. Right. So we go on with the FBBT, faculties. So we have three full-time faculties. And the first one is Dr. Anin Anos, the program operators. And then we have Rosetta Pont, very same professor here, about 30 years in IITs. And then we have myself, in food engineering, and we have supporting staff with the program and so on. So we have three faculty, we have different research focus. So Dr. Anin mostly he work with the food and pharmaceutical biotechnologies, so and so. And then cell tissue culture, encapsulation, control release of drug, whatever, active components. And Rosetta Pont mostly with the his experts in post-supply technologies, very senior. And then with the cereal brands and all the related to the stack, whatever. All right. And for myself, I work with mostly with the food engineering, medical modeling of food process, and then new technologies like high pressure processing and visible light processing of food. And we also working with the waste recycling, for active compound, converting into the more value-added products. And also we developing a new areas in the sensor development for food safety applications also. So on average, we have currently about more than 10 PhD students working in different projects. And then we have about more than 25 master students every year. Totally, sorry. All right, so maybe it's easy to look at here. We have the research focus combined by our students here in the last few years. So you can see here we deal with very diverse areas, depend on the faculty's expertise. So we can work with the enzyme DNA technologies in some research, and then we focus our attention on the food and pharmaceutical products, encapsulation technologies, where we try to develop a control release of active compound in food products. All right. And then other part also with the post-supply technologies and other like waste resistance, for example. So some of the main projects going on now, and we just would like to introduce briefly here. All right. So the first one we have project with the microalgae for high value products. So basically we analyze biomass for the nutrient component there, and we can see how we apply this biomass for food, for other pharmaceutical products. And this one's still going on. Another big area is the antibiotic residues and antibiotic resistant bacteria inside the food and food supply chains. So in the last few years, we work with the meat products, with the seafood, and even last year we worked with the vegetable products. So we identify many bacteria with the resistant to antibiotics, or multiple resistant to antibiotics. So then we try to identify, characterize them, and we come up with approach how to eliminate in the future, for example. And it's still going on, very big research area right now. Another one is we developed a kind of new source of probiotics from different sources. So we can isolate it from the animal guts, or maybe from the fish guts, whatever. So many different types of those probiotics and biotics also in food products for applications. Another area we also working very active right now is the biotic compound extract. So we have something here working with those areas. We isolate it and quantify, and we characterize them, and we see how they can be used in many applications, like in in pharmaceutical products, or maybe in food products like antioxidant, or maybe other applications as well. So depend on our faculty expertise, we work on diverse areas. You can see from here, combine both engineering and biotechnology also. All right, this one is for my research focus. So I work mainly with three main areas. Number one is with the sensor developments for food safety applications. So with the chemical sensor, with the biosensor also, right? And then the second one is the waste recycling and regulations. And number three will be with the numerical simulation of food process food products process. Okay. All right. Here, so I just want to go through some of the main research focus here. All right. So my background is with non-thermal processing. Non-thermal means we use some new technology to process the food without using the heat products. So in US for the last 20 years, some very active area like high pressure processing, and then we have the PAF, polaritic fields, and recently we have the light, visible light, okay, UV light, whatever. Okay, right. So in that area, we are trying to set up some of the main research in AETs. And then we also develop some area we can share both the facility for both sensor for the redox behavior of food products can relate to other property of that like compounds. For example, in this slide, you can see we develop a low-cost sensor for tetracycline detections. Okay, so this background you can see here. All right, so we have the SPCE or screen printing electrodes. Low-cost one can buy it about 15 baht. Okay, one piece. All right, so on the top of this one, we will coat with a contain polymer and then the nanoparticle there. Okay, so we use a target like the tetracyclines, or maybe you can apply for the same concept for other things like the toxic substance, or maybe we can apply for pesticide, apply for hormones inside the food product when we detect. So you use that as a template to print it on this surface, and when we remove that template, they leave a cavity over there, and that cavity can be used at the recognition site for the targets in the future. So when we use this sensor to put inside a solution or put inside some food products there, we can detect the targets easily and very sensitively. All right. So here we our main focus is on the conducting polymer. And in this case we use the polyperols. You can see two SEM picture there showing the background of the electrodes with a different porosity. Okay. So the same concept we try to improve it in the future. We can apply for the food metrics, and also maybe you can expand it for other kind of toxin and other things also. Maybe in the future we can apply it for food pathogens, bacteria, so on. All right. So this one is just so us the performance of our sensor here. Now we go down to the micromoles levels. So it's about 0.5 micromoles. All right. So and we hope with some improvements we can incorporate some new material like the graphene or other things. We can even lower down the detection limit to the nanomoles level, but it takes some more time for us to develop that. And we're trying to limit the cost of our sensor to a low cost one, so we don't want to use too many expensive material there. Make it simple, make it cheap, okay, and make it disposable after use. All right. I'm also working on another branch of this sensing platform. We work with a tiny device we call the microfluidic device. So this device, maybe they have another name, the chip, okay, lab on the chips. So we can use this one with the very low consumption of chemical, okay, and rapid detection of the toxin of the target, like the pathogen inside the food products. So this one we can develop a concept, and then we can make it with certain prototype in the lab, okay, the low cost one, and from there we can try to build up, okay, in more complicated, okay, production technology. All right, and we can make it a complete piece of prototype there. And in Southeast Asia especially, we have a lot of productions, food productions, and still the ongoing problem is the waste, especially the protein waste. Let's say in the oil industry, we have a lot of oil cakes, and in the other kind of food waste like the fish proteins and other things are same. So one of our area we try to convert this waste into kind of the value-added ingredients for food. Maybe you can use for personal food also. All right. So we have one student who work on this like peanut proteins, and she tried to hydrolyze this and characterize the property of this hydrolysis. So mostly we found that this one have certain good performance in emulsifying activities or in antioxidant activity there. I just want to quickly, you hear me, my many slides they're not like so completely. All right. So in the future we want to move a little further with this one at the background, the platform. We want to make it maybe conjugate it to other substance, maybe the mineral one, or with other kind of nutrients can be delivered to the human body easily. Or we can try to control the release inside the human body. Similar example is for the fish skins. So in Southeast Asia, the volume of fish production is huge. A few million tons per year for all the Thailand, Vietnam, and other countries of Bangladesh. So a lot of fish. So when the fish they just get the fillets freezed and export the fillet only. So remaining the gut and the skin and all kind of protein will be down at the waste. So currently mostly the fish protein used at the animal feed, very low cost, and they can sell for a very low price, not much. Okay. So we try to make use of this one, and we can convert them into high value products like for food ingredients. Okay. So we first develop a process to hydrolyze this, and then we can examine identify the protein inside the emulsions. Okay, mostly. So we try with some initial research first, and we found that it's very positive, especially in emulsions and in the fried products. So these kind of like ingredients they can enhance significantly the oxidative stability of the products. So if you add it to emulsion, it can extend the cell life significantly compared to the control sample. Or if you add it to the frame fried sample also, you can see a very different in oxidative stability of the final products. So this was going on research there, and we more than welcome any suggestion or maybe collaboration in the future. All right. So our project mostly we have the support and partnership from many different places. We have the support from the Royal Thai governments, and then also from the scholarship from the Queen's scholarship, and then Food Science Australia and many organizations. And also we have some projects funded by the FAO and also by IDB in the past. All right, so the main focus is for us for training. So we have graduate programs for master PhD students every year. We graduate more than 10 master and mostly with the research and trainings. But at the same time, we try to develop some other activity outside as well. Maybe the training modules, or maybe we develop with some industry, technical capacity building. So we trying to expand it in other countries and regions right now. And we also involved in the conference organizations and other of the kind of consultations activities. All right, so that's very short introduction about our programs, and feel free to raise any question. Not only for me, but also our US presenter in our session here. Okay, thank you.